Hello, so in this video we will start with the list interface. So in first video we learn what is collection framework, what are the different interfaces available. So in this video we'll go with a list interface. So I'll go with list demo. I'll create a class, and inside this class I'll create a main method, and here I will write list. Okay, list equal to new. We can implement the there are multiple classes which are implementing the list interface, right? We have array list. Okay, so that we will see first, and we have set, queue, different, right? So first we'll start with the list. So I created list equal to new array list. Okay, so what is the characteristics of the list interface? So list interface will maintain the insertion order. Okay, insertion order. So if you want to maintain the insertion order, you will go with a list interface. Okay, or the classes implemented by the list interface, let's say array list, linked list, queue. Okay, but again inside array list also it has some special characteristics, when to use array list, when to use linked list, that we will see in after some time. But what is common in all these classes which are implementing list interface, which is maintain insertion order, then allow duplicates including null. Okay, including null, and it has a index based access, so we can access by index. Okay, so array list is internally using the arrays itself. Okay, arrays itself. So array will start with a 0 index, 0 1 2 3 4 5 6, right? So you can get the element of any index using this one. So this is the common for list, right? So here it is giving the warning because it says okay, change the type. Okay, we need to provide what kind of this list, integer. Okay, and here also we need to pass a integer, but in a latest version now it is not required. So even if I add it here, it is grayed out. So we can replace this with the symbol, this symbol, arrow symbol, and here it is array list. Okay, we can write a array list also. Array list integer equal to new array list. So I created one collection of type integer. Okay, collection of type integer, and now we will see what are the different actions we can perform. List dot add. Okay, list dot add, we can add a number, let's say 10. Okay, similarly I'll just replicate it and I'll add multiple numbers like 1, then 5, then 1 again, because it allow duplicates also, right? 7, 20, 40, 20, and here I will add null because it allow null also, right? Can we add one more null value? Yes, it allow multiple nulls also, duplicates also. And finally we can print using the system.out.println list. That's it. So we added some elements, and it maintained the insertion order also. So if you see the order in which we added, like 10 1 5 1, okay, 7 20 40 20, 2 times null also it is printing. So it maintained the insertion order. It allow duplicates including null, that we have seen it here. Okay, and 20 also duplicate, 1 is also duplicate, and we can access this based on the index. So what does this mean? So if I write here list dot get, like add method which will add the element to array list, we can get the element by index also. So index start with a 0, right? So here this is a 0th index, this is first index, this is second index. So if I need a 5, I will write get 2, means get a second index element, and now if I run it, it is printing 5, right? So similarly how we get it, we can remove also. So if I write here list remove, and we can provide the index also. Now the 5 will get removed. So 5 will get removed. So you see the 5 is not there, 5 is removed from this list. Okay, so 5 is removed from this. So we have a remove first also. Let's say I want to remove this 10. So what I can do here is I can write list dot remove first. Okay, no need to pass the index, so it will remove the 10 now. So if you see 10 is removed. Okay, then we have a similarly remove last also. List dot remove last. okay, and this will remove last element, which is null. 2 times null is there, right? So only one is remaining. So we have seen this also. But okay, what is the specific thing with array list? Because list we know, like it maintain insertion order, it allow duplicate including null, index based access is there. But what is specific to the arrays here? Okay, so we will see that also. So before that, let me bring this visual representation. So this is how our elements are stored, and these red colors are the indexes. So if I need 50 index element, I can use 5 here, right? So we can perform different operation. We can insert something. Let's say if I add 7, so you see 7 is added at the end. Okay, 7 is added at the end. Okay, so don't go with this why it is shifting here, but let's consider it will just add 7 in the list. Okay, now if I want to update something, okay, I need to pass where I need to update and what value. So at third place I want to add one element, right? So our elements will get shifted. Okay, our elements will get shifted. Let's say I want to add something after 5, between 5 and 1. Okay, so what is the index? 3. So here I want to add something, right? So for that there is a method list. Okay, I'll add it above, like list dot add. We can give an index 3, and instead of this add 100. Okay, so 100 will get added after this 5, and other elements will shift. Now the index of this one will be 4, and index of 100 will be 3. Okay, so this is how it will happen. So 10 we removed, right? 1 1 5 also we removed. So we'll see 100 will get added there, right? And 1 is still there, so other element will shift down, right? That's how it works. Okay, but I don't want to shift, I want to replace 100 itself. So we have a method called dot set. Okay, third index, instead of 100 add 200. Okay, set will replace, but add its overridden method which will append. Now if you see 1 200 1, so this will replace the value, but this will add the value in between, and array will shift. Okay, array will shift. So let's see another method which is available, list dot, we have remove trim to size. What is trim to size here? So if I run this one, nothing will happen, right? So everything is same here. Okay, but I will show you like what change actually when we use trim to size. So when we create an array, we have not mentioned this array list, we have not mentioned the size here, right? So size will get increased dynamically. So default size of this, default capacity of this array list will be 10. Okay, so if you go inside this code also and search default capacity, and if you see the default capacity is 10. So whenever we create this line of code, internally one array is created with size of 10 by default, and when we start adding the element, it will add the element inside the array. And let's say if I write here system.out.println, okay, and list dot size. So what is the size of the array? So the 11, right? So but I told you the internally by default it create a array with 10 size, right? When we add this last element, the array size, array will check, okay, if there is enough space, no, right? Then internally it will increase the capacity to 1 by 1.5 times. Okay, internally it will increase the capacity by 1.5. But what will happen, like there are 11 elements, and now the capacity maybe initially it was 10, now it is 25, but we still have element. So other array is like empty currently, right? Here if you see this 13 14 15 16 17 is empty, it is not utilized. And to remove that blank array indexes, we use trim to size. So this will remove the unused capacity, and the capacity also now will be 11 because of this method. otherwise capacity will be different and number of elements are 11. Okay, but what if I want to store like 3 elements, because I told you the default capacity is 10. If I want to store like 2 elements, other elements are not used, right? So I can give the initial capacity in the constructor also, you see, 2. Or I want to store 100 elements. So means intentionally we are telling, okay, set the initial capacity with 100, means create array of 100. So I may add more elements up to 100 into this list. Okay, so that's how we can add it here. Another method we have is set. We have seen last, remove, for each, there, clear. So clear will clear the array. Okay, so if I run it, we'll see the blank array, right? So it cleared the array. Okay, so this also I will comment out. And next we will see list dot ensure capacity. Okay, so we can set some minimum capacity of the array. Okay, minimum 100 size of array. Increase the capacity of ArrayList instance if necessary. Okay, if required, it will increase the capacity. Okay, and that's it. So another is list dot we have for each, there is empty also. We can check if it is empty or not. So this will return a boolean, right? Is empty. Okay, I want to check if this array list is empty or not. So we can use this method, is empty. So it will return a false because our array list is not empty, right? Similarly, we can write list dot for each. I want to print all the elements, so we can use for each loop, and it take consumer. So if you don't know consumer, you can watch out my another video related to Java stream. So there I explain the functional interfaces. This is a functional interface, and lambda expression and method reference also I have explained there. So here we are using method reference. So consumer will take method reference, system dot out. So in this class I want to refer println method, that's it, and it will iterate and print in one line. You see the array is printed here using the for each loop. Okay, and method reference. Okay, so let me move to next one. Next we have list dot, and if we go here we have iterator also, remove if. Okay, take a predicate. Again, this is a functional interface. So remove if means, let's say if my array contains 200, okay, or I want to remove the even numbers from this list. So what I can do, pass the lambda expression. Let's say take any number. If number is modular by 2 equal to 0, then remove it, and that's it. So it will remove the even numbers. Okay, so cannot invoke integer int value because n is null, right? So on null this expression is failing, right? So let me comment out these two nulls, and if I run it again, so all the even numbers are removed. So this is something 4 is coming from this size, I think. So we have size also, right? So if I comment this also and run it again, now we see 1517. So all even numbers are removed. Then we have list dot add to the last. Okay, if I want to add something to the end of the array list, we can add it. So you see at the end it is added. So there is method add first also, right? Add first, right? I want to add 0 and run it. So you will see 0 is added at the first, right? Similarly, we have list dot trim to size. We have seen there are replace also. If you want to replace, add first, contains also we can check. If this list contains let's say 7, okay, it will again return a boolean expression. Okay, if list contains 7 or not, so it will return a true. So if I run it again, you will see the true is printed. Okay, similarly list dot, we will see we can convert to array. There are a number of methods are available. last index of, I want last index of 1. Okay, I want last index of 1, right? So it will give the int, so system.out.println I. So what is the last index of 1? It will print. So last index of 1 is 3, so it will start with 0 1 2 3. So at third index we have a last 1, so that also we can see. Okay, so now I'll just uncomment this thing. Okay, and this also, the reason is whatever the methods we see, all are not coming from ArrayList. Okay, so these are part of list interface, these are part of list interface, and some are coming from ArrayList. So how we can check? Because this list, ArrayList is implementing list, I can store in the list reference also, right? And now if I add a list here, you see these two methods are showing error, because trim to size and ensure capacity is part of ArrayList class, it is not a part of list interface. So if I go to copy this one and go to list interface, and if I search here, we'll not find trim to size. But if I go to ArrayList, we'll find this method, trim to size is there, right? And this is the public void method, right? So that's how, like if you want to use all this method, you can return type should be ArrayList. Okay, otherwise you can keep it as a list also. Okay, I hope this is clear. And let's see like when we can use this one ArrayList. If you want frequent insertion, if you want to get some element from the ArrayList, then go with the ArrayList, because ArrayList is faster for like frequent accessing the data. Okay, frequently accessing the data. So let me show you some more examples. Let me comment out this one. Okay, how to create an array list. So there are different ways. One, we have seen this one, we can add the element, but there are more also. Okay, there are more ways to create a list also, so we will see that now. One is arrays as list, arrays as list, and if I pass here 1 2 3 4 5 6, okay, and if I store this in some variable, this is the list 1. Again, this is a list of integer, right? And this list of integer is a fixed size of array. Okay, it is a fixed size of array. We cannot add anything to this list, or you cannot remove anything from list. Only you can use a set operation, you can update. So if you want to see it, like let's see list dot add, and if I add a 10, okay, it is not giving me any error, but if I run this code, you will get an exception. Okay, you will get exception. Let me print it. We have not printed, right? List 1, sorry, we have not added to list 1, right? So that's why list 1. Now the add will give the error, because we cannot modify this fixed size of array when you use arrays as a list. Even we cannot remove also. If I write remove here, I want to remove 3, okay, then also you will get error, because we cannot remove also. But we can update using set. I want to update 0 index 1 index, I want to update at 1 index, I want to replace 100 with 100. So now if you see, the array is changed, 1 instead of 2, it is put 100 now. So we can update, but we cannot add or remove. Okay, so this is what about the array list. And there is another one, list dot off. Okay, we can create like this also, and here also we can pass 1 2 3 4 5 6. Okay, and if I check the return type of this one, this is again list of integer, right? Let me comment out this also. So what is the difference in the list of? It is immutable list. You cannot add, remove, or even modify also, and it does not allow null element. Okay, if I try to add here null or just null, it will not work. Okay, it will not work, it will give an error. Okay, integers, it will throw an error, null pointer exception, right? So you cannot have null value here. Even if I try to update it, it will not work. Integers dot set 1 index, put 100, this will not, nothing is allowed here. No addition, removal, updation, nothing is allowed. Okay, it is immutable when we create with the list of. Okay, I hope this is clear. What is the difference between list interface and array list, when to use array list. Okay, so there are multiple another ways how we can create an array list. All right, so list of integers L1 equal to new array list, this we have already seen, and then we can add an element. Another is list of integer L2 equal to arrays as list. Okay, arrays as list, as I told you about, right? So this is another way. Another is list of integer L3 equal to list of, which I have shown you, right? List of, but you know the what are the restrictions. If you create like this, you cannot add, remove or update. In this one you cannot add and remove, but you can update. Okay, and one more is there, list of integers L4 equal to new array list, and we can pass here L3 also. Okay, so this list we are passing it here. Similarly, we can pass L2 also here. Okay, so this is also possible, we can use like this also. Okay, so now we will just recall what we need to remember. Okay, so finally, list, what is common? Insertion order, allow duplicates, and it has index-based access. But when to use array list, because we have linked list also, which will work similarly, right? So when to use array list, if you want to frequently access random access, right? Randomly want to access some elements frequently, so then you can go with a array list, because it by index you can get the element very fast, and add and get, the complexity is big of O of 1. Okay, so that's all about the array list, and we'll see about the linked list also, which is better for frequent insertion and deletion. Okay, if you want to frequently insert something and delete something from the collection, you can go with linked list, but array list is better for like if you want to frequently access, read operation you want to do it. Okay, so that's all about the array list. Next we'll see the linked list, which is part of list interface. Thank you, and if you have not subscribed to the channel, please consider subscribing and put your comment in the chat box. Thank you.